All right. Week 3, day 2. Welcome back, May 26th. This morning, I want to go over an exercise that has been, I think, fun, interesting, rewarding. I've gotten decent feedback about it that we'll do in 2 weeks. So not next week. Next week, we got the Excel refresher crash course. But then after that, I'd like to carve out some time to apply Excel to do what we've talked about in principle, grabbing some data and analyzing it. But in order to answer a question, so for the assignment, what I need you guys to do is think about something that you've been curious about that can be explored using data that you can likely get from the internet. For example, we're at hockey playoff time now. I was curious. Didn't look into it, but this is kind of an example of what I'm talking about. I didn't look into it, but I'm curious, like what like team level statistics indicate success in the playoffs, or win loss ratio, whatever. Are older teams stronger, or is youth? Some of those old guys are pretty slow, but they're experienced, so is age an indicator? Is size? Are big teams, big strong hockey teams more successful? Or you can look at football and look at weight, or average time in the 40, those sorts of things. Another thing that came up that I did look into was during tax season. I was doing my taxes and paying my Arkansas income tax, and right around the same time the bill came in for my property tax. So I was like, man, we pay a lot. And we've got a 9.5% sales tax, which is about as high as anywhere I've ever paid that I can remember. So I started looking into how we compared to other states, and we spend more than others, than relatively than most other states. I think we were number 5 in per capita spending, like $10,000, something like that, a person. So I started thinking, well, what's Arkansas getting for its money? What's our education level for that amount of spending? What's our, are we safer? Are we better educated? And then I know there's a happiness a happiness score that was done a couple of years ago. That's something that I've been building on a little bit. It provides a happiness score for the states, so that you can then rank the states from most miserable as far as how the people feel living there, to happiest. And so that's what I started with, just as an example, just to get folks into doing a research project in Excel. Is Kaylin Brown actually Dexter? Is that who? I know one of y'all was sharing a login or sharing a computer.
Yes, sir. It's me.
Good morning, Dexter. Yeah, I was just going over what we're going to, a project I want to show you, or an exercise I want to show you, so that you can start thinking about what you want to do. It's just a free form, basically use Excel to go do some data analysis on whatever you want to, on whatever interests you. And I was giving some examples from sports and government. So let me share kind of what I did and what I'm looking for. And again, this will be after the Excel um, after the Excel boot camp next week, the Excel 2-day Excel workshop next week. So we'll work on this uh, next month, actually. Okay, so here is um, the product of my project. You guys won't, you don't have to do this in PowerPoint. If you want to clean up Excel and use Excel tabs to do something similar, that's fine. But this also introduces a little bit about research methodologies. Again, you don't have to go into this level of depth. I just want you guys to just take some time and have some fun using these tools. But in research design, I'm sure you all remember from school, if not more recently, you've got a hypothesis. It's an idea. I think perhaps something is related to something else, or something will cause something else. So the way you see this written up in scientific journals and whatnot is in the form of a null hypothesis and an alternate hypothesis. And again, you guys, I mean, it's a good Google, but I'm not worried so much about this. You guys can just, I wanted to find the relationship between this and that, or the ranking of something. You don't have to worry about this alternate null hypothesis wording, but I wanted to throw it in there just for GPs. So the null hypothesis, when they're doing scientific research, like COVID vaccine research or anything like that, is that there's nothing to see here. The null hypothesis would be our vaccine has no effect on the transmissibility of COVID-19. That's why it's called null. It's kind of like the nothing to see here hypothesis. Your alternate hypothesis is that there is something significant. There is a measurable reduction in transmissibility, or like for a drug trial, there's a reduction in blood pressure or cholesterol level or whatever the case may be. And depending on the research you're doing and the criteria, you can set a threshold of value, like it reduces blood pressure by at least 5 points, because other research has shown that a reduction in 5 points has an effect on mortality, or lifespan, or whatever that's worth reaching for. So you can assign that sort of a threshold, but you can also put a statistical significance threshold that with 95% confidence, because all of these trials are a sample. They never give the pill and the placebo to the entire population. So you're taking a sample of people in this drug trial. So depending on the size of your sample, the better confidence you have in your result. So that'll also be part of your alternate hypothesis, with 95% confidence level, we've decreased blood pressure, or this pill decreases blood pressure by 5%, something like that. So that's the basics behind a null and a alternate hypothesis. And again, there's tons of information on that out there, if it applies, or if you're curious. So my hypothesis, I was thinking that people were happier when it's warmer, just because I've talked to so many people that live up north, and they're like, oh yeah, but in the winter, because it's overcast and it's cold, and you got to scrape your window, and you got to plow plow the snow. And I'm thinking, maybe people in Florida or Hawaii or whatever are happier than people in Michigan or Minnesota because they're in a sunnier climate. That seasonal affective disorder, that's a real thing, for a number of people. So that's what I wanted to look into, just like I said, just as an example of getting into some data, and doing some correlation and ranking comparisons, and then presenting the results. So this is kind of like your final project, where it will be a beginning to end, um, starting with a business question, moving through accessing the data, describing what you had to do to the data, uh, um, figuring out your model. For me, my model was correlation, Pearson's correlation, because I've got a continuous happiness score and a continuous average high temperature, through to presenting the results of your analysis. So like I said, this is low pressure, something fun. Here in a couple of weeks, everybody will show what they've come up with. Any questions so far?
No, sir.
Okay, so my null hypothesis was that average daily high temperature and happiness are not correlated. Because my real hypothesis was the alternate hypothesis. There is something there. um, and I put it into two. There's a there's a positive correlation and there's a negative correlation. The data will dictate whether you accept or reject the null hypothesis and accept or reject the alternate hypothesis. And this is the way they phrase it in all the academic literature. So that was my hypothesis, that I wanted to look at temperature and happiness. So I would also like for you guys to show the data source, where you got your data from. So for me, happiness scores I got from an article written by some like college professors. It wasn't just a blog article, but on a site called Wallet Hub, the happiest states, and they had a happiness score that was derived from like 9 other variables. There's the URL for it if you'd like to look for that. Yeah, I'll post this. I'll post these slides under the Excel module. And then I got average temperatures from a currentresults.com website. You can get this kind of stuff depending. A lot of it's on Wikipedia, and it's pretty easy to pull into a spreadsheet. And then my model, my analysis was a simple scatter plot in Excel. So along my x-axis here, I've got temperature. And remember, that's your independent variable. That's the thing you don't really have control over. It's what causes the change in the y variable. Causes or doesn't cause, but that's the way you map this out. Temperature across the x-axis going from, these are average daily highs throughout the year. So yeah, some of your data points towards the right here are what you would think, Florida, Hawaii, Arizona, those sort of things. And then going up the left-hand scale, we had this happiness score that they came up with, that was like a 0 to 100. And you see the peak value is at about a 70. That's as happy as anybody gets, is a 70 out of 100. So so when you scatter plot this, you can instantly see that it looks fairly random. It doesn't look like there's a strong linked change in y as you move from left to right in X. So it doesn't look like there's a strong correlation But in Excel, you can add the equation and the R squared value, which are probably pretty faint, but they're on the right side of the chart there. So R, which can be negative to show a negative correlation, that, when the independent variable goes up, Y actually goes down. And R squared, you square it so that it's always a positive number. But yeah, your R -1,4, that's a weak correlation, and the negative means that they're negatively correlated. So my my findings. Any questions on this scatter plot or what I put up there?
No, sir.
Going once, going twice.
No, I don't have any questions.
Cool. Okay, so yeah, two continuous variables with a nearly the same scale make for a pretty understandable scatter plot. So my findings in this little project, R can be from -1 to 1, both ends of that scale being a strong negative or positive correlation. R value of -0.14 is correlated. It's away from 0, but it's very weak. Up around 0.5, you start to say that it's correlated. Anything above 0.5 is considered a strong correlation or reason to accept that they are correlated. Okay, so -0.14. Recommendation: accept the null hypothesis. Temperature and happiness are not correlated, and reject both of my alternate hypotheses. So that was the project and the findings. The Excel portion, I have a spreadsheet that I'm going to continue building here with U.S. states, which was my core data, and here's my column F is my happiness score. Column E was the average temperature. And I had to do some wrangling with this, some cutting and pasting to get the data.
We can't see your Excel.
Thank you. Never assume that I know what I'm doing here, guys. Good job. So I'll just do screen. Okay, so I keep a few tabs. I've got the raw data of my state names that I use to build all of the variables I have for each state, or that I'm continuing to build. Actual population. Here's the average temperature and happiness score that I used from that last one. The thing that I was just talking about this morning about taxation spending is in column G here. And that scale bothered me a little bit because it's compared to something like happiness, where that's 0 to 100 and spending goes from 0 to 11,000. Sometimes the closer the scales are to your two continuous variables, the better the scatter plot looks, or more meaningful the scatter plot looks. But anyway, so I'm going to keep building on this and add and kind of change from the happiness versus temperature thing. What I'm going to work up is a few more metrics and a few more different kinds of charts to story tell state, public spending versus other metrics that you might think would be related. So like for example, I don't know if you guys have ever messed around with one of these kind of maps before, but if I select my state and I'm holding control and pressing the left mouse button to select G, if I do a filled map for example, here it is. We start to see, this is an interesting way to look geographically at values. And you can see it automatically, this is one click, one mouse click, it automatically throws the scale on the upper right-hand side and shows the minimum public spending in a state and the maximum public spending, $19,328 in state spending. I don't know how they do it, but it looks like that data point, and these maps are fairly interactive. Nope, Oregon is close though. Yeah, the darker the state, the more per capita they spend. Was it North Dakota that was? Yeah, North Dakota. I don't know what's up with that, but that's what I wanted. That's what I will investigate. You might the I don't know, the book term for this would be exploratory data analysis, where you kind of come up with an idea, then you start asking more questions of the data to see what's the deal. But one thing that I was kind of surprised by was Arkansas at 10,585 was I want to say we were number 5. So let me kill this chart. And if I do, let me insert a table here. Usually makes things a little. No, that ain't right. That ain't right. Inside the data, insert table. I think that grabbed everything. Yeah. So converting your worksheet into a table sometimes helps. So I wanted to sort by spending per capita. Sort by smallest to largest, largest to smallest. Bam. Good old Arkansas. So row 8, which is number 7. Yeah. So I thought that's pretty high compared to some of the states that you might think. Massachusetts certainly ranked higher than us in like education. 27th, I would have thought. They call it Taxachusetts. I would have thought it would have been higher. So there you go. But I'm going to keep working on this. And part of the data storytelling will be, where you got the data from and any transformations you had to make. So you can do it all in Excel or pop back and forth from PowerPoint to Excel. But yeah, use graphs and transformations and whatnot. Like this transformation here is just literally dividing by 1,000 to get it down to something that's a more similar scale to my happiness. And I didn't see a correlation there either. Let's see if I click on happiness and per capita spending in thousands and then insert a scatter plot. It's kind of random looking. So anyway, yeah, and we'll do more plotting and data analysis and whatnot with Excel next week. So that's just a preview. Just so think about something that struck your mind that involves data that you're going to be able to get a hold of. So maybe check out like all of that data is available. List of states with their crime rate, their spending, all of that is on Wikipedia, and they'll have data within the last couple of years. It doesn't have to be perfectly recent data or anything like that. It's just an exercise to get you guys moving through an A to Z, a front to back data analysis project. Any questions on that?
No, sir.
Cool. I'll reiterate and expand mine a little bit and um, go through that again on I guess Tuesday, 2 weeks from now. Okay. So that was that. Let me put some stuff away. Everybody's good to go on Python exercise 1. That's great. Let's go ahead and take 10 minutes. If you want to, I'm going to go through notebook 5 lists and tuples, which are Python's version of an array, basically, and just kind of go through the how those are handled with Python, some functions and methods and particulars. So I'll be going over notebook 5. Let's come back at 10 after 9.
All right.
All right. Okay, second hour. Going to go over notebook 5. But before I do, I wanted to share another statistical measure. And again, you guys that have studied math probably already know all this, but when I was looking at state data, sometimes you've got a continuous measure like average daily high temperature or spending per capita. And sometimes you see things that are where it's ranked, a ranking, and they don't give you easily the underlying data, or sometimes there is no underlying data because it's subjective. And so I started looking at, well, how do you compare rankings? It's not something I'm really, intimately familiar with. So this is like 5:30 this morning. I got up and I was dorking around. There's actually a mathematical measure for that called Kendall Tau. And then the other one was RBO. Hang on, Kendall Tau versus RHO. Kendall Tau gives you it's like literally Kendall, the name Kendall, and the name Tau, T-A-U. It gives you a negative 1-to-1 correlation between two lists of ranked things, like states ranked by education versus income or something like that. But if they're both ranked, so it's almost like and another thing it can be used for is to like in research, if you ask multiple people to rank their favorite whatever, name the top 5 bands ever or the top 5 albums. In your opinion, who are the best television shows ever, top 10? So you get these ranked lists, and then you can look at them and it goes through the math to see, a perfect match gives you some level of similarity, and if the same value is on both lists but off by a couple of different values, it just, and it we're goes through this this algorithm to see how correlated two ranked lists are, as opposed to how correlated two continuous variables are. I thought it was interesting. Anyway, I think I'll do a little more research on that one. It was Kendall Tau, and what in the heck? It had it had some weaknesses, and there was another one, and it was called RPO. rank order or something or other. Anyway, I'll find it. Okay, so let's go to number 5, lists and tuples. Clear all my output, share my screen. And this data, it's a class in Python. I would consider it maybe a data structure more than a data type, but that's just me. Lists and tuples. It's a sequence data type. Again, I consider it a data structure because you can have different data types. You can have different types of data within the list. And these things are virtually identical, but it does introduce the topic of mutable versus immutable variables in Python. Mutable just means you can change what's in it. And a tuple is immutable. You can't change any of the cells once you assign a member to a tuple. You can't change one of those list members from something to something else. But they operate virtually the same, and according to my reading, the only difference is some performance. It might be programmatically, it might be better if you don't want some future programmer or yourself to modify the tuple. The convention is if it's a set list that you're never going to change within your program, use a tuple. But anyway, all this is a list of things. So it can hold data of the same or different types, and we'll see 3 examples of that here in just a minute. Every member of the list you would refer to as an element, kind of like a row if you look at the list as a column. So there we go. And we have we did this in the looping in the last notebook so that we could loop through the list. And if you remember, the range function operates on a list, and we'll see a little bit more examples of that this time. So this first one, student numbers, is a list of 5 numeric literals, integer literals. Movies is a list of 5 string literals, and employee is all over the map. It's a list of it's an integer literal, numeric literal, a string literal, and a floating point literal. And you can also have lists of lists. So keep that in mind. That's where you kind of start to get something that looks kind of like a data frame or a worksheet, is the list of lists. Okay, so we'll run that. All that did was assign it. You're not seeing any output there because we didn't do anything to put any output on the screen. And the next one, we're printing what's in them. And you see that those lists were appropriately assigned. So the square bracket, remember that one, because depending on, there's basically 3 different sequence objects that we'll deal with: list, tuple, and dictionary. And they each use a different character for the syntax out here. So we use a square bracket to enclose a list. Okay. There is a list function, just like, you know, how we convert float to int and int to float. And strings, we convert strings to int and float by using int, float, and str. We've got an exact same type of function called list that will convert like a tuple to a list, or it will convert the output from our range function to its own list. So the output from a range function is a list, but the list function actually converts it to its own list that you can then assign to a variable. So this fives is going to give you a list of starting with 5 to up to pretty sure it's not including. I haven't run this in a little while. Up to, but not including 100 by fives. So this list should look like 5, 10, 15, 20, all the way up to 95, I think. Let's see what we get. Yeah, it's, remember the range function, the second parameter in the range function is up to, but not including. And then your third parameter is the multiple. Okay, so now we have a list called fives that is full of every number, multiples of 5 from 0 to 100. Okay, now you can, in Python, it lets you do a lot of stuff that you can't do in other languages. But like, for example, if you multiply a list, it's not like it goes in there and multiplies 5 by 3 and 10 by 3 and 15 by 3 or anything mathematical like that. All it does is repeat the list 3 times. So more fives equals fives times 3 will give you that 5, 10, 15, 20 through 95. It'll give it to you 3 times. 1, 2, 3. There you go. So this can be handy if you're maybe creating dummy data, something like that, or you need a list that will iterate, and you need to do something with it, maybe other than just as a loop variable, because you can use the range function for that. You don't need to store it anywhere. So anyway, this is the way that's the way it works. So you can access a an individual element. You can loop through the elements. The elements are each individual value in there. So we had several lists up here that we declared. Student numbers is this first one of 1, 2, 3, 5, 6 student numbers. I'm sorry, not 5, 6 student numbers. So we can loop through that list of student numbers using this for loop here. And here's one through the, double clicked on my markdown cell. Let me execute that again, Control Enter. Oh, that's a good example on happy accident there, like Bob Ross has. If you want to do, remember, if you want to do literal in a markdown cell, literal code elements, you use these back ticks. Takes a little getting used to that sequence there, that syntax. So I execute that and come down here to my code cell, which will actually do those commands. And we get, of course, in order, we get our student numbers list and our employees list. So you can also refer to an element of the list by its index. Its index is the number, the nth member of the list. And it begins with the first element is 0. Remember, it's just like everything else in Python. It's 0 based. So the 0th element of a list is the first element. So you always got to remember that. Just like in our for loop, we had to add 1 because it's up to but not including. and it starts at 0. For loop starts at 0, or the range function starts at 0 by default. Okay, so we can print specific members of a list. Yeah, employee 0, 693. Remember, employee. Our first element. Our first element is 693, but we refer to it as the 0th element in Python. That bugs me. You don't do that in any of the other programming languages anybody, are any of y'all Java trained?
No, sir.
I took a semester of Java, but I can't remember most any of it.
Yeah, I think most of them are like you would think. Cell 1 is cell 1. Why would it be 0? Yeah, a lot of things are 0 based like that. R works the same way. It's got to have something to do with mathematicians or something. Anyway, that's how it works. 0 is the first one, and if you use a negative, it like goes to the end of the list and wraps around. So negative index numbers can be used to identify an element relative to the end of the list. So movies -2, intuitively, I would think it would be Star Wars. -1 would be Heidi. -2 would be Star Wars. Let's see. Test that theory. Star Wars. There you go. Just like you'd think. That one operates like you'd think. And since lists are changeable, we can change the value of the element inside of the list. We need the index number. So instead of 693, let's change the first cell from 693 to 999, and then print out the list. And then, oh, by the way, remember employee had different values. So let's use the type function, which checks the data type, and print those out. So it started out at 693. We changed it to 999. And the members of the list follow the conventional rules for Python. So 999 is an integer. John Cleese in quotes is a string, and 89500.0 is a float, like you'd think. And the type of employee itself is list. So it gives you an idea of what's going on internally there. Let's see here. So we can declare a list like we did up here, where we listed the individual members. We can declare a blank list, just like to get it started, like an initial value of nothing, so that you can then operate on it later. So students blank times 5 is what you'd think. It's going to create a list of 5 elements, all of them being blank. And then we're setting cell 2 and cell 0, element 2 and element 0, sorry, to Jimmy and Sue, and then printing that out. So blank, 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 and then and then 2 of them have values, 2 of them or 3 of them are blank. And you can concatenate lists. And again, it doesn't do anything fancy like you might think of, going through the lists and adding, doing math within the list or anything like that. All that plus sign does is very, very similar to concatenating values in the print function. It just sticks them next to each other. So faculty We started a 3 thing, and then we already have student numbers, right? So that's what we just did. That was students. Yeah, student numbers is our 6-member list from the very beginning. So we run that, and we see that student numbers will come first, and then these new faculty numbers will be at the end. Okay, and you can use the same abbreviated operators for lists as you can. I mean, for numbers, and you can use those for lists. So faculty numbers plus equals movies is the same syntax as saying faculty numbers equals faculty numbers plus movies. So when we run this cell, we should get the faculty numbers and then the list of movies like Star Wars and Scarface. And we'll run that. Bam, there you go. Just like you would think. Okay. Then any questions? We've got Python exercises 2 today that will give you some practice looping through stuff, and a list will help because a couple of the problems are basically getting the user to fill up a list for you.
So no questions right now.
All right, thanks guys. Okay, and you can loop through elements with a while loop, but I guess you might want to loop. You might want to use a while loop in a list because intuitively, you'd want to go through the entire list. But it may be that you only want to go through the list until you hit a condition, and you could have 1 million members in the list. And it could be that you sort them and you don't want to go all the way to the end checking values. If you hit a condition, you want to stop going through the list. So that might be an example of where you would use a while list instead of a for loop. I mean, a while loop instead of a for loop. Okay, so what we're saying is that index, which is going to be good. I didn't give it away. What do you call index in this looping construct per our discussion on Tuesday? Remember, there were three kinds of things we used inside of a loop to help control our logic.
In the sentinel and
Yeah, those 3 things. What would you call index in this one?
It's a counter, isn't it?
I would call it a counter because it's not really accumulating anything. You had accumulator, counter, and sentinel. So we're not really, adding up a value to be used for something like an accumulator variable like we did last time. So I would call it a counter. Yeah. So now we know how many times we've where we're at in the list. So we know, see, this is kind of hard coded, and it's an interesting concept here. We're looping 6 times. If you look in here, we don't ever really test anything. We're going to go through that list 6 times. We don't know the length of the list, except for the fact that we just literally assign the length of it. But I think there are student numbers. No, faculty numbers has 7 in it. Student numbers has 6. So anyway, we're going to run through that and print out those 6 numbers. But let's go back and if we used an index of 7 or 9, say, now what happens? Because we're using this index, we're starting at 0, the first element, and going through to the 9th element, but there aren't 9 elements. So let's see what happens with that one. Bam. List index out of range. So you, by practice, by convention, would rarely want to hard code this sort of stuff, just in case, because you might change the list membership. 3 months from now, you might come back to this program and change the list membership and not realize that you counted on the length of that list in subsequent code. So we'll do it the smart way here coming up. Change that back to 6. Now it works. So yeah, the len is like you would think. The length of the list returns an integer number that you can then use for looping or decision logic or whatever you need. It tells you the number of elements in that list, even blank elements or null elements. So we set the len, we print the len, print len, and I added a new line. Why did I do that? Oh, it's just a blank line. That just adds a second blank line between this print statement and the next one down here. So we set index equal to 0. And then we say while index is less than the length of student numbers. So now it doesn't matter how long, how many elements there are. It will dynamically run through that loop. So you probably want to use that that len function if you're ever looping. If you're looping through a list, which you'll be doing here in about a half hour, 45 minutes. Okay. No questions on that so far? Okay. Yeah, len is returns an integer value, an integer type. Okay, so list slicing. You're going to see this concept of slicing coming up here frequently. This is the way you do substringing. Like if you only wanted the first 4 characters of a string, like a lot of times in Excel, you'll have like the first 3 characters will be like the account type or something like that. So there's some intelligence loaded into the data and you want to grab just those characters. So there's like left and right functions in Excel, where there's it's slightly different in Python. There's always more than one way to do this stuff, it seems. But this is the base format for grabbing part of a list. And it's like, generally speaking, it's a contiguous part of the list. Like a start, end, and then, but you can tell it to skip. If you add this step value, it will, like every other member of the list, if for whatever reason you've got alternating data that makes sense like that, which you run into every once in a while. Some data is it's called long data versus wide, and you'll have 3 rows or 5 rows of information that all pertain to the same whatever account, and they're all in the same column, or all they're all stacked above each other as opposed to next to each other in columns. So in that case, something like this would be useful as well. So we have our to select a range of elements from the list, we have a start, colon, end, and I want to say it's not up to, but not including the end. Oh, I don't even know. But that, there you go. Up to, but not including the second parameter here. And then you have this optional third parameter if you want to step by something other than one, including negative if you want to go backwards for some strange reason. Okay, so we are going to reuse our movies, but give it a new set of elements. Scarface, The Blob, Star Wars, Heidi, It, Big and Up. Run that. No output since we didn't ask for any. Okay. So I commented these out so it wouldn't give things away. Start at 2, end 4. Somebody that hasn't run this, what does starting at 2 and ending at 4, what's that going to return? Has everybody ran it already? Have everybody uncommented everything and ran it already?
Is it Star Wars too big?
2 to 4. I'm going to say
Or to it, maybe?
2 is actually 3. So Star
hiding.
Wars, yeah, Star Wars. And you're going to stop at 4, but not including 4.
Star Wars and Heidi then.
So
right.
it's Star Wars is what I'm thinking. Let me intuitively. And again, guys, I haven't run this in a while. So let's print that one. Let's run that. I'm uncommenting that first line of code. No, it is Star Wars and Heidi. Start and end, but not including the 4th, which is actually the 5th. There you go. 1, 2, 3, 4, 5. So yeah, up to, but not including it. So yeah, there you go. Star Wars and Heidi. And I guess no matter what, you're always going to get end minus beginning number of elements. 4 minus 2 is 2. You're always going to get 2 elements if you look at it that way. So there you go. Okay. And then if you omit the first element, it defaults to the first or 0th. So it's 0, which is Scarface, up to but not including cell 3, which is actually cell 4, which is Heidi. So you should get Scarface, The Blob, and Star Wars on that second one. Run that. Yeah, Scarface, The Blob, Star Wars. The next one, we start at 1, which is actually The Blob. It's actually the second one and goes to the end. If you omit the end parameter in a slicing syntax like this, it defaults to the end. So we'll run that, and we should start at The Blob and go to the end of the list. Yep, there you go. Next one, movies, -4 should be -1 is up, right? 1, 2, 3, 4. Shouldn't that start at Heidi and go to the end? Anybody got
Yes.
a different prediction? Start at Heidi, yep, and go back to the right to the end. If you omit both, you get the whole thing. So not really sure what the utility of that would be. And you can use variables, remember, inside of this slicing syntax. Those don't have to be numeric literals. Remember, I think we used, well, we weren't slicing, but we used the variable index up here when we were iterating through student numbers. So just keep that in mind. And then we print the whole thing, which will be identical to what we just did. And then 1, start 1, end 4, skip by 2. Looks like it should be 1 is not the first one, it's the second one. So it should be The Blob, and then skip 2 to Heidi. But then our end is 4, which is actually the 5th, which is it. 1, 2, 3, 4, 5. So I'm thinking we're going to see Star Wars and I'm sorry, the Blob and Heidi. Whoop, I didn't uncomment it. Hill. The Blob and Heidi. There you go. So that's how you grab slices, subsets of a list or a tuple or a string variable. You do the exact same thing with a string, and we'll cover those in a different notebook because there are a lot of other methods and functions that work on strings. 9:44. We came back at 9:45. We came back at 10 after. Let's see how much more of this I got. Yeah, I think we will need to take a break here in a couple of minutes. Okay, and there are wonderful, powerful functions and methods to the list. Remember, list is a class, and like movies is an object of the class list. And we have methods that operate on a list object. So that's coming up here. So the in operator, we're going to enter a movie name, and we're going to see if we can. We're going to put it in the variable search, and then we're going to see if we find movies or find search in that list. So enter a movie name. I'm going to enter the movie It. Not found. Wait a second. I see it. It's right there. What happened?
You didn't capitalize the I.
Humor me. There you go, guys. It's case sensitive. Of course. How would it know? So depending on what you're doing, you can temporarily check the upper case of a string against something, just in case they, the data is weird, or the user's, not smart enough to enter something case sensitive. Yeah. So big, found it. So that's how there's an in operator. I want to say that's the same syntax as SQL. Pretty sure when you do a subquery that returns multiple values, we see if something is in that subquery. So there you go. That's easy enough to check if something is in the list. And again, if case sensitivity is an issue, you've got the dot upper and dot lower methods for a string. Okay, so remember methods and functions. A method is a behavior inherent to the class, the code for doing that. Like this next example is appending a new element to the end of a list. That behavior is coded within the declaration of the list class. But when you use a function that you're not calling with this object dot method syntax, that logic is written out in the base. A function is written out in the base language library. So there are lots of methods that you can do on a movie, and I'll show you that in the next thing. So we're appending not Sparta. Spartacus to the end. Okay, and then let's comment this out. I want to show you this is a way to get help. So we've got this movies object, right? If you want to see anytime you're blasting through your code, if you type in one of your objects, regardless of what class that object is, type dot and then hit tab. Tab is like an autocomplete in Python. I don't think we've talked about it, but it can come in handy in Notebook, and it also works in most IDEs. So you hit tab. I just hit tab, and it gives me a little menu of methods. These are things that I can do to a list object, or things that I can do with. I can clear the list. I can append something to the end. I can make a copy of the list. I think, side note, I'm pretty sure that Python is pass by reference on lists. And if I say, like right now, movies 2 equals movies, I'm pretty sure movies 2 would point to movies in memory. It wouldn't make a whole new copy of movies in memory. Pretty sure that there's nuances in Python where you have to remember how it handles pass by reference versus pass by values. Happy to go into that in more detail if I've confused anybody. Just let me know. So you can clear a list. You can count. I don't know the difference between length and count. Let's try it. Movies.count. And if we just do the parenthesis, I'm curious if that's yeah, you got to send it something. Takes an argument. Maybe it's count of things that are in that list. Yeah, big is in there one time. So so that is a really handy help methodology. Is you type in the name of an object and then dot and then hit tab, and it will remind you, because there's so many of these things, and it's easy to forget which ones are available. And then, of course, you know, if you need the actual language syntax, you can always pop down the help and go to the Python reference, which is the actual, no kidding, language reference manual. I generally use tutorial sites because they're better. They come with examples that are a little more clear. But the Python reference is lock on accurate, and if you get used to the way it refers to things, it's probably more concise than a tutorial site. So yeah, you can reverse the order, sort it. There's a bunch of stuff you can do, and you just click on that list. You just click on the method that you're looking for. Okay. Movies.count the blob. Ah, it's right there. Good grief. Such a space. There you go. And the index method will look through the list and tell you which index, which element number it is in the list. So the blob is 1. Remember, it's not, because Scarface is 0. The blob is 1, and the type of the index, the data type of an index, is integer, which again, data types matter in Python. Okay, just a couple more cells here and we'll wrap it up after the break. let's see here. Yeah, printing the list and inserting at an index. If the insert method of the list object lets you stick a value in at the index that you prescribe. If you use a negative, it does just like the what do you call it? The slicing that we did just a little while ago. And if you use something that's past the end of the list, it sticks it on the end of the list. So it won't error, which kind of helps. So we're going to stick some new movies in here. And I want to say -5. Not sure what that's going to wind up being, but we'll run that whole block here. So when we get done, yeah, we got Superman, Get Out, Scarface, The Blob, Star Wars, Ben, Heidi, It, and It. We got duplicates. Big, Up, Spartacus, and Jaws. And yeah, it stuck Jaws at the end because it was beyond the end of the list. 97 is a index that's outside of range. But anyway, so here we got it. Now we got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 elements in our list. And of course, there is a sort method that will go through and sort the list in by default. It's like alphabetical order. You can change it. You can sort it by like the size of the arrays. And I want to say it has trouble. I don't know that we'll get to it in here, but it has trouble when it's mixed data types within a list. It works better when it's homogeneous, when it's all the same data type. Okay, so we're going to sort movies, and then we're going to print it out, and then we're going to reverse it, which is the same as sorting in reverse equals true. It's just another way to do it. We'll print those out. So movies sort, and then movies, it goes in alphabetical order like you would expect. And then we reverse it, and it goes descending alphabetical order. And then they both work, but I don't remember if I get to it here. I was looking at this morning. Hang on just a sec. There's a function called sorted that returns a sorted version of the list, but it doesn't actually change the sort order of the list like the sort method. I wanted to hang on. I don't remember seeing it in this notebook. So let me cover this real quick and then we'll take a break. Let's see. Where'd I go? Okay. In this one. So we sorted the movies and printed it out. Let me get a new code cell. So I want to say movies.reverse. Whoop. No. Need another code cell. Now print movies. Here's another autocomplete I want to show you. Whenever you are typing, sometimes you want to use long variable names, right? Long, meaningful variable names. Well, if you type in a variable name and then press tab, it looks in memory for all of the identifiers, all the variables that you have declared, and proposes, or if it's unique already, it auto completes that variable. So here it gives us objects and and other built-in things for you to choose from. We wanted movies. So I'm going to run that. All I did was hit tab. So yeah, since I reversed it, it's now in alphabetical order ascending. Get another code cell. And I want to say print sorted movies. I'm going off script here, guys. So if I blow it, oh, sorted movies, and then I think there's a equal true. How that works, I think. Bam. Yeah. So it sorted, the sorted function will also sort a list, but it doesn't change the value. Let me get one more code cell and print movies again to prove that. It's still in that order. So there you go. The difference between a function and a method. The method actually does it. So I want to get rid of all this garbage for next time. Let's see here. Cut that and cut that and cut that and cut that. And when we come back, we'll start pulling things off of the list using a method. Okay. Let's take 10, come back at 10:10, and we'll finish out this notebook, and then I'll give you the rest of the day to do Python exercises 2. Any questions before I take a break?
No questions.
Doing good? Okay. I must be a fantastic teacher, right? Everything I'm explaining is so clear. It can't be that you guys are excellent students and experienced programmers. It's got to be me, right?
Yes.
Yes.
Man, this is a tough audience. You are a tough crowd. All right, guys. 10:10. See you back in 9 minutes. Okay. Welcome back. Third and final hour, May 26th. Okay, this next one, the remove method will delete a value from the list, the first occurrence of something from a list. Print that out. So we removed Star Wars, and you see it doesn't just turn it into a null, it actually removes it from the list. So remember that. Deleting an item, if you want it, that's by the exact name of the element, or the exact what's the value of the element. If you want to delete something at an index value, you just give it the same syntax as we've used before. But it's a del function, built-in function. So we deleted movies to 2, which is actually the third one. 1, 2. So we deleted get out. Get out. Okay. So there's functions. These are functions: min, max, sum, and min, that return, just like you would think, information about the elements in a list, the minimum, maximum, sum of student numbers. I'm going to try an experiment here. We've got a list. I can't remember what it was. Employer, or way back here, that had different, yeah, employee. I don't think I've messed around with employee. I want to see what happens when we do like the sum of employee. I want to say that when you have a list of different variable types, it can cause some trouble. So let's do print sum of, and if I type in EMP and hit tab, the only memory object that I have is employee. So when I typed in EMP and hit tab, it kept me from having to type in loyee, the full value, which is really handy if you're using nice long variable names. So just remember that tab key is pretty handy. So if we were to sum employee, bam, yeah, you just need to be careful when you're doing things with lists that contain different variable types, just like you need to be careful anytime whenever you're dealing with Python data types or Python variables, because if you do the wrong thing with the wrong data type variable, it will crash. Okay, if you want to make a copy of the list, it is passed by reference. Yeah, I thought I covered that. So if you want to make a copy of the list, you actually have to, you can't just say movies 2 equals movies and think that you've got a second copy of movies in memory. Just something to remember. So if you say cinema equals movies, like the whole list, you either have to slice the whole list or use a loop. But I want to say that you can use the copy method. I don't think I covered that. But anyway, when I made cinema here, I didn't just say cinema equals movies. I said cinema equals movies, and I used the slicing notation. So that will make a fresh copy of all the elements in a list. Or you can, if it makes sense, you can do that in it. You can append those items to a list. Here's shows.append within a loop, and that actually builds the loop. So there we got another copy of it. But like I was saying, if you do films equals movies and then print films, and then we append get out to the movies object again and put it back there because we took it out just a minute ago, remember? And then print films, you'll see that it you're not actually, films isn't actually a separate independent copy. It's a pointer to movies in memory. So films equals movies just copies the location of the movies object. It doesn't make a fresh copy of it. You guys would interrupt me if that was confusing, right? In computer science, that's, go ahead.
Yes, sir. It's pretty self-explanatory. Yeah. I understand what you're going with it.
There you go. If you've never worked with pointers and memory locations, it can be a little confusing. And in Python, you're not always sure, and you just got to kind of remember and work with it. So cool. There we go. Calculating list totals or averages. This is a good example of where we're having an accumulator and a counter, and then printing out the result of, this is just an average. But again, you've got the do we not have a average? Min, max, sum, min. I thought there was an average method. Anyway, here's an example of an adding up a bunch of stuff and then using your counter and your accumulator to create a running average. Just an example. If those were, I mean, you wouldn't normally add or average a student number, but that's how you would do that. But I wanted to say there was an average. I got to go off script. Sorry, guys. I apologize. I do. If my curiosity is not helpful to you guys, but when I get curious about something, I instantly think that I'm probably making you curious about it. So I wanted to try this one time. I'm thinking that there is a, what did we say? What are we working with here? Student. So if I say stud and hit enter or tab, I'm sorry, we get student numbers dot. Now this will tell me all of the list methods because I'm using a list object and then I'm hitting tab. I could have swore there was an average. Nope, there's not. Okay, there you go. So you got to calculate that, or there may be in another library. There may be like in the math library, or one of the more intense NumPy maybe. There may be a built-in function if you convert a list to a NumPy array. I'm probably getting ahead of myself. So anyway, here is a programming exercise and solved. So this is going to be similar to what I'm asking you guys to do in the exercise today. The Python exercise is 2. So design and write a program that enters the sales for days of the week and totals it up. So we've got an initialized list of 0, 7 floating point numbers, and another initialized list that has our days of the week. And then we just go through and have the user input it. And we have an accumulator variable that adds that all up as we go through the loop and then prints it out. So there's some good code sample for you. $834 worth. Okay, 2-dimensional lists. This is a list of lists. So this and that can be a little confusing, but it also can be really handy. So it could be that my 2-dimensional list bracket 0 equals another list like movies or employee or any of the other stuff that we've done here. So that's a 2-dimensional array, 2-dimensional list of lists. It's kind of like a table, depending on how you set it up. So it literally column and row. And this is like some syntax for how you would set it up, row and column. But we're not going to work with lists of lists or arrays of arrays. And there are, folks in hardcore math that are doing multi-dimensional arrays. So what we're going to work with is a good old pandas data frame, like I showed you last class. Like I load my CSV up to check my invoices. So there you go. But you can have a list of lists, and you can refer to row and column kind of in a pandas data frame as well. So, which you do frequently. So that's the way we're going to tackle that particular problem. Okay, so now tuples, just a little bit about this, because they are exactly like a list, only notice, like I said, there's square brackets on a list. It's round like a function call almost, when you are doing a tuple, but you index them the same way. And this will show you the data type. So it looks at those parentheses and automatically types that as a tuple instead of a list. Okay, tuple looping. Same as same. But now watch what happens. If we append Superman, bam, you can't append anything to it. You can't go in and change Star Trek to Star Wars. Once you create a tuple, it's intended to be kind of like a constant instead of a variable. There you go. Okay, so what? Like on large lists, apparently they're faster. I've never really researched that because I don't use million item lists, or haven't had to yet. This is where I was talking about they're safer. If it's something like a constant, like a lookup value, it's safer to create it as a tuple so that when you're programming, you don't accidentally screw up and change something that you didn't really intend to. That could be something, maybe you can read values out of a file and turn it into a tuple that's kind of like a lookup to see if something is valid or not. We can connect to a SQL database, do the same exact thing, which is one of the things we will do in the course, connect to a SQL database. And you can convert them. If you need to change it, all you got to do is we're create movie tuple is being created using just like int, just like float, just like stir. We can create just like we use the list function. There's a tuple function that does that data type conversion for you. So you just say tuple of a list. You send a list to the tuple function and it returns a list. It doesn't change it at all. It just changes the data type. And you can change it back again. This is almost like the pennies in my hand. Now it's in the other hand from 6 cents. And back to the way they were, list and tuple. So yeah, tuples are no different than working with a list, just the fact that they're immutable, unchangeable. Any questions?
No, sir.
Okay, and I had y'all look at Python problems too last on Tuesday, and nobody had any questions on that. If you're having any trouble with your code, best thing to do is email me. Cut and paste your code into an email if you're getting something wrong, and I'll turn around and paste that into a notebook and get back to you as quickly as I can.
Also, I was gonna say, it said the assignment is due today.
I would like for you, we got 2 hours left. I'd like for you guys to use classroom time, but I apologize. Dexter, is that you talking?
Yes, sir.
I know you're on shift work and you're probably off the clock right now, right?
Yes, sir.
Yeah, this is admirable of you to be attending class in real time. I got all the respect in the world for you for doing that. But I would say no, don't turn this in by 12:30 today. Do it the next time you're on the clock.
Yes, sir.
All right. And everybody else, if you're on the clock, yeah, please use the next 2 hours, knock this out. If this is easy, shoot me an email. I've been Googling this stuff for a while now. I've got some other looping exercises that may be more challenging for you. If you're looking for a challenge, shoot me an email. Otherwise, any questions or concerns before we adjourn for the day? Let me real quick. Python exercises 2. Nope, not that one. Go back to assignments. Python exercises 2. Assignments. And it is due. Yeah, I said today at 1. But yeah, Dexter, don't sweat it.
Yes, sir.
Yeah, don't. And in fact, don't ever sweat being late. Just shoot me an email. Let me know what's going on, so I'm not worried about you.
Yes, sir.
Cool. Okay, guys. I'll see you Tuesday morning at 8:30 for our 2-day Excel refresher crash course workshop.
All right.
Okay.
See you on
Sounds good.
Tuesday.
See you
Take care,
Tuesday.
guys.
Thank you.
Have a good weekend. Long weekend, right?
Yes, sir.
There you go. Enjoy it.